Awesome. So you want to go and get going with presentations, or should I go first here?
Well, we can do intros first. I'm Claire, software engineer at Speckle. I've been with Speckle for almost a year now, working mostly on developing in C#.NET with our connectors in Rhino, Revit, AutoCAD, Civil 3D, and a few others. And before, my background is in architecture, and before Speckle, I was at AECtech for a few years, working mostly on developing some internal computation scripts and then some BIM interop as well. Alan.
Nice. Well, hi everyone. My name is Alan Rynne. I'm also part of the Speckle team. I've been working at Speckle for a little over a year already. Started in October last year. And I've been mainly also coding in C#, but also doing some of the front-end stuff. And in the latest months, I've been doing several demo app integrations and other fun little small projects related to Speckle, which one of them we will see today and walk through the different parts and how to build it. Before that, I was in a couple of lesser-known engineering firms doing mostly R&D related to Grasshopper and programming geometry in general. And that's about it.
Cool. All right, we can get started with the presentation. All right, so for today's masterclass, we're going to look at real-time data visualizations using Speckle's developer platform. We're going to be building a web app with Vue.js and a backend server with our Python SDK. And some of the web apps that we've built before are more or less proof of concepts that you can use Speckle as a development platform and infrastructure to build whatever you need to build internally. One example that Alan put together quite recently is an app where you can use webhooks to get live notifications when any updates to your stream is made from Revit, and it'll generate a carbon report automatically from the data in that stream. Another fun, these are all like one-day development exercises. Another fun one was building an app, a simple front-end app, web app that allows you to take a pic, and on the back end, it'll generate a 3D point cloud using some Python ML libraries, and then push that back. And then today we're going to look at a web app that will track model changes visually. So again, using our infrastructure, when you update your model, it'll run some very basic analysis on the model meshes to try and determine what geometry has changed and where. So this app has two main pieces, and you'll see that in our repo in the walkthrough later on. The first is a front-end web app where you can select the different versions of the model that you've pushed to your Speckle server, and then generate what we're calling a difference, or like a diff result for those two models. And to begin with, we're going to cover some very basic concepts of what is Speckle, what is our platform, all of the pieces of our developer platform, and then some basic development concepts. So to answer the what is Speckle question, we're first going to cover what is Speckle and then go through the developer platform and core concepts. We'll run through a live demo of the app that you just saw, and then do a code walkthrough / DIY session if you want to follow along, and then finally leave some time for Q&A. So yes, what is Speckle? Speckle is a data platform that has three main features. The first is collaboration. So it allows you to send and receive data from multiple applications. We have quite a few connectors in our ecosystem now, like Rhino, Revit, AutoCAD, some game engine connectors with Unity and Unreal. We have Blender and some data connectors like Power BI and Excel, and a new one for structural engineering, ETABS, among many others. Speckle also allows you to version your models. So traditionally, instead of keeping track of changes file by file, when you use our platform, you actually get object level versioning. So changes at the object level are tracked as well. And then finally, it's very easy to automate with Speckle as well because of our developer platform. So being able to really curate and control the data that you send and how those data are permutated and designed for your own internal use is quite straightforward. And Speckle has three main pieces. We have Speckle Web. This is where you can access features for project coordination. You can get notifications when your teammates have added you to their projects and so on and so forth. We also have a nice web viewer on the front end as well. We have our app connectors, as mentioned previously. This is how you can extract and receive data to and from Speckle. And then finally, we have our developer platform, which includes SDKs, APIs, and a bunch of documentation and guides to help you start customizing your Speckle experience. General question of why should you develop with Speckle? I think one is that you get a network effect when using our platform, because every additional connector we add to our ecosystem, the more data you have access to. We'll go more in depth into the back end of how these objects are created and sent between connectors, but essentially they all have the same underlying format in the back end. So regardless of where they came from, you are able to receive them in every other connector that we have built. Also, we're fully open source, so you can take a look at our repos, whether it's to clone our repo and hack your own version, or just to take a peek and understand and learn how we're building. Open source is a great way to spread knowledge in our domain. And finally, we're community powered. So in addition to just building a platform and cool features, we're also trying to build a good community around Speckle. This means that you can draw from a growing pool of active developers and users for help, resources, and new ideas. So the core Speckle developer experience has three components. We'll go through the features first. So as mentioned, we have C# and Python SDKs. All of our core methods are mirrored between those SDKs. We also have a GraphQL and REST API for you to query your data. And finally, we have a lot of additional packages like desktop UI that we're using for our connectors, and you'll see fairly soon. We have our web viewer, which Alan has made embeddable, and it's quite cool to use in other platforms. And we've also recently introduced webhooks for live notifications. And all of our libraries and kits are available via NuGet, NPM, and pip. So the first part.
Sorry, Claire. It's worth noting that our viewer is going to be heavily upgraded in the following weeks. So we're not going to get very much into the viewer because the whole viewer is going to change in maximum 2-3 weeks. So keep an eye on the upcoming tutorials for that. We will use a viewer though. It will just skip over the most complexity.
They are very
Sorry for the
exciting
interruption.
changes.
Yeah.
All right, so the first part of the core Speckle developer experience is essentially defining your data. We'll get into more technical aspects of all of the terminology that we're using in this section, but essentially everything that is sent to and from the Speckle server is a base object, and this is a highly flexible object that you can customize yourself. The next aspect of development is managing your data once you've created it. So being able to organize them on the server and being able to send and receive those objects to and from the server is with our APIs is the second piece. And then the third piece is retrieving your data. Again, depending on what you're looking to use the data for, whether you just need to browse the properties or when you need to fully deserialize your data, we have both GraphQL and REST APIs for that. And yeah, this section, we're gonna just go over basic Speckle developer concepts. So a lot of the terms that we're gonna be using, like a base object, streams, branches, commits, we'll review. The first main topic is the base object. This is the building block of Speckle and basically how everything, what everything is built upon. Our base object has a few very simple properties. First is an ID. This is a serialized hash of the object and unique to every single object. We also include an optional application ID. So if you are creating this object from another API like Rhino or Revit, you can attach an application ID to your base object. We have a Speckle type property, which is a concatenation of the assembly name and its inheritance hierarchy. And then finally, total children count, which is keeps track of the number of detachable objects. And we'll explain object nesting and detaching later. So how this works with our interop is that objects from host applications like Revit or Rhino are converted into Speckle base objects. They have additional properties on top of the ones that you saw on the screen, and they are serialized to our server and then deserialized when you back into their native API forms when you receive them back in your Revit or Rhino or other connector applications. So these base objects are highly flexible. You can nest them as well. Say you define a wall class that inherits from our base object class. You can add additional properties like a height. In addition to primitive properties, you can actually also attach another base object to that first base object, and we'll go into attaching and detaching more in depth later if people are interested. But essentially, when you nest base objects, you can detach the base object, which means that when it's serialized, say you have a bunch of walls with a bunch of slabs as properties attached, but you have when you detach the property, it means that when it's serialized, the detached property, in this case, the floors, will only be serialized once. So it will yield much better performance. Our objects kit is a kit that we include that has predefined and developed base objects for you. They fall into a few categories. We have our primitives, which currently we're only using intervals. We have our geometry objects, so points, lines, arcs, ellipses, NURBS, curves, BREPs, meshes. Those all fall under our geometry category. We have built elements, which are built on top of our geometry objects. And these are supposed to capture more semantically complex objects within our connector ecosystem, primarily from Revit, but also from, for instance, civil applications like Civil 3D and open roads. So these are things like walls, beams, columns, alignments, and more. And these built elements also have application-specific inheritances as well. We have a fairly comprehensive Revit kit. And we have structural objects that were very, very recently added as well, used for primarily ETABs, I believe, currently. And finally, an additional category that includes objects such as blocks, which we can send currently between AutoCAD, Rhino, SketchUp, and a few other applications, Unreal, I believe. We also support things like display styles, render materials, hatches, and text. So the second part of the development platform concept review is on our Speckle server. So our server, the way that we organize all of our objects is in what we call streams, branches, and commits. And these all live on our Speckle server, whether it's our public server or one that you deploy internally. By default, every single time you create a stream will have a main branch. And when you send and receive data, it will by default go to the main branch. When you send data to any stream branch, we refer to these as commits. They're basically snapshots of whatever data you are sending to your server. And each commit will contain information like who sent it, when they sent it, the application they sent it from, and a comment that you can, an optional comment describing what's in the commit. And fun fact, a commit is really just another base object under the hood. So they all have their own unique hash IDs as well that you can use to retrieve them later. And finally, in your streams, you can create additional branches if you'd like to keep track of data in parallel to your main branch. So for instance, if you wanted to create a separate branch just to run through some iterations on a facade that you're generating in Grasshopper, you can do that very easily without while keeping your data on your main branch separate and organized. So finally, or actually not finally, almost finally, we have our client operations. So when you're building an app on top of Speckle, there are a few key concepts that that we'll go over in terms of how to communicate with our Speckle server. The first is whenever you create a Speckle client, uses tokens to determine whether or not your local account has access to your Speckle server's API. This is usually retrieved with a post request. And the other major concept is the use of transports. These are defined in our SDKs. Essentially, transports are used to query your servers, our Speckle server's API endpoints, which will allow you to retrieve, do things like retrieve specific data, whether it's a stream, commit from the stream, an object from a stream, and it'll allow you to also perform CRUD operations on your streams and branches themselves. And yes, in our SDKs, we wrap these queries for you in a convenient method. So instead of actually building out your GraphQL query, you can just access those specific items directly from a few simple methods. And finally, once you send the query, the transport will respond with a payload that contains your serialized JSON objects, which are representations of the objects that you are retrieving, and those can either be deserialized on receive if necessary, or they will be deserialized on receive and then parsed accordingly, depending on what you're trying to retrieve from the query itself. So putting that all together, we will be building a Speckle app from almost scratch. And I guess we can get started with a summary of the tech stack for this app and a diagram conceptually of how we want to arrange all of our pieces and what needs to communicate with what, and then we'll do a live demo and maybe take a break after that before we get into the code walkthrough. So yes, currently the app is not deployed at that address, but we can build it locally. The code is available on our Speckle Systems GitHub, which I linked in the chat. And the app that we're building uses the Vue framework, Vue.js framework, and our Speckle viewer on the front end, and we're using Speckle's Python SDK combined with Fast API server for calculating differences in our model geometry on the back end. And let's go through the app diagram first before we do the demo. So conceptually, this is a diagram of what our app is. Like we will be, it's divided in two main pieces, as discussed, the web app and the backend server. So generally, the way that we're communicating is between the web app and the Speckle server to retrieve information to display that the user will see. Between the backend and the server also to retrieve information for actually processing the data that we have stored on our Speckle server. And then finally, between the web app and the server that we are building to communicate between the generated results and displaying that back to the end user. So the steps are fairly straightforward. First, we have our front-end web app that will authenticate with our Speckle server. Once it's authenticated, you'll be able to see the streams that you have access to, and you can select the specific commits that you'd like to compare to each other. And once you select the commits, you'll send a query to the server that we have set up. The server has two endpoints that we'll look at shortly. And then once the server receives the diff query, it will retrieve the corresponding commit objects. Here we're going to be comparing the display meshes of the data that we're sending. And once the meshes are compared and we color them nicely to display what geometry has changed and what hasn't, we'll create a new commit on a diff branch of the stream and send that commit back to our front end web app, and that completes the loop. So I think now, Alan, you can do a live demo of what we've built.
Hopefully, if everything actually works. Let me just share. You have to stop sharing first, and then share this. Oh no, I need to open preferences. Maybe I need to escape the meeting and come back. One sec. Classic. Ring Central. Yeah, I need to quit and reopen. I'll be right. There you go. Sorry for that. Now it appears I do have access. Share. There you go. Hopefully you can all see my screen with the fantastic Revit model open. So let's kind of get to it from the very beginning. In order for Speckle to actually work, you require in any of your desktop apps, or at least most of them, it requires for you to have the Speckle Manager installed, which you can find, I think, in the README. We added a link. If not, let us know. We can share the link fast in the Slack channel or the chat. And basically, this is where you can set up all of your accounts to the different servers that you have access to. In this case, I have several, but most of you guys will just use our publicly available server, speckle.xyz. And you can also directly install the connectors from here. In this case, we're going to be using the Revit Connector, which you just need to go to the manager and hit install. And we'll also finally be using the Rhino connector, if everything goes well, to receive the final diff information back into an authoring software that is not the original authoring software. So you can kind of like bounce around to your data. In this case, I've already have everything installed, so don't have to really do anything here. And once you have installed it, this is, for example, Revit 2021. Let me just move this bar somewhere else. It's annoying. There you go. So in the add-ins tab, you will have the Revit connector, and you will also see this second button because we have a new UI that we're gonna phase out the old one for the new one. But for now, we're gonna stick with the classic old UI. So once you open it, it basically is empty, and you need to or you have the ability to add streams to this specific Revit file. So in this case, I'm just going to create a new stream. You can select from this dropdown any of your accounts. I'm going to use the Speckle XYZ account, so I can actually share the stream URL with you guys, and you can see it online. And just going to hit create new stream. It will automatically create a nice name for us that we can also edit. And we can also go check at any point in time this stream in the browser. So in this case, since we just created it, like right now, there is not really any data here. It's just like an empty box waiting for you to fill it in. Where is the chat here? I lost my Slack. I'm gonna paste this in Slack because I lost my. There you go. So this stream is currently, where am I? Here. This stream is currently set to private, meaning that if you go to this link, you will not be able to see anything, even if you have an account in Speckle XYZ. But you can also make it public, which means that anybody in the server with an account in the server and with this specific link will be able to access your stream and see its data and also receive it in any software that we have connectors for. So let me just save that to make it public. I can also add some collaborators to my stream to allow people to either view it in their own app as if it were part of their streams, instead of having to physically know this weird URL. So I'm just going to add Claire to this. I never know which Claire it is, the right Claire.
I think
so
the bottom one.
I'm just going to add both. And I think it doesn't find you anymore.
That one should work.
Yeah. So you also have like 3 options to give access to people. You can have a reviewer, which is something that somebody that can only read your data but cannot change that data in the server. You have a contributor, that is someone that can change, read, and write data. and you can be an owner, which means that you can also modify the settings in this stream, including name, collaborators, adding new webhooks, etc. No, so anything that is not like purely sending and receiving data, you would need to be an owner to do so. So I'm gonna make Claire an owner too, but technically everybody else should be able to access this stream already with an account once you're logged in into the Speckle XYZ, and you should be seeing exactly what we're seeing right now, absolutely nothing. So let's fix that. In this stream that we added appears as a card in the Speckle UI in Revit. And this middle button that says 0 objects here allows you to select using different selection types. So in this case, we're gonna just go for, you can use an actual physical selection of objects that you manually selected from your model, or you can use some sort of predefined filters that we provide. In this case, there's several things that you can do. You can filter by category, by view, send just the project information, send absolutely everything, or filter by a specific parameter. So everything that matches a specific parameter with a specific value or whatever. In this case, what I'm gonna do is just gonna send one floor to keep things simple for everyone. So I'm gonna go to my view filter, and I'm gonna search for floor level 1, and I set filter, and my filter will be set to level 1. And now when I press send, the UI will ask me for an optional message. If you don't fill in anything and just double click the send button, it will start sending with a predefined message, but I can also add a specific message to it. So my first Revit design proposal, and hit send. And this will basically start doing its thing. It will read all of the objects that you've created, convert them all into the Speckle object model that Claire was explaining before, and convert those to JSON and send that JSON to the server to be stored and viewed. So as you can see now in our page that I haven't even refreshed, it automatically detects new changes for you. Now we have my first Revit design proposal commit that is on the main branch, and it's coming from Revit 2021. So all of the information of where your data comes from, when was it sent, where does it live, etc. It's attached to each commit. And we can also preview that commit real quick to see that everything is fine and according to what we actually sent. It does look like the level 1 of the famous Revit house, and it doesn't seem to be missing anything. So let's go ahead and do some changes to this model and send it again, so we can actually do a comparison in our app. No, so we're just basically now we're just preparing, setting the stage to be able to do an actual diff operation between 2 different commits. No. So now I'm gonna go to my level 1, and I'm just gonna wreck a little bit everything, not very precise. I'm just gonna grab the sofa. I'm gonna move it closer to the fireplace. I'm also gonna grab these chairs. Can I grab these 2 chairs at the same time, please, Revit? It doesn't seem to be wanting me to do so. There you go. I'm gonna move these chairs nice and cozy next to the fireplace, and I'm gonna bring a couple of the seats right in the middle. No, so something pretty simple. And now I'm gonna go to the kitchen, and I'm gonna say, okay, I no longer need any of these tables. So I'm gonna kill that, all of these objects, and I'm gonna just redecorate the whole thing more minimalistically. And I'm also gonna remove, what am I gonna remove? This door. There you go. Beautiful. So now that we've actually modified some stuff, notice that we've already had the selection that we selected previously. It's already saved into our stream, so we don't need to reselect the same filter. The same filter is already applied for us. So we just need to write a new commit message and hit send if we want to send again. So this would be a reorganization of living room and kitchen, for example. And this will again do its thing. Eventually, we will get this new commit created alert that we can actually ask it to view it. And we should be seeing this thing that is missing a table. And so a couple of changes that on clear side, it's very difficult to actually know what exactly has changed just by seeing this. You assume some things have changed, but you're not really 100% into how it has changed and where and what exact objects have been modified. So which is where our app comes in. So let me just start from the beginning. I'm going to actually log out there. Can I do this? Beautiful. So if I will log into my app, which will basically ask me, very typical, just like Google and any other authentication provider, it basically asks you to allow the app to have access to some of your data, and you can actually review the data that your app is going to have access to. If you deny, well, nothing will happen, so you better allow it. So once we're allow, we will get redirected to our website, and now we will have our user logged in as ourselves, in this case my account, but it should be each individual person with their account. And once we have that, our app will first display a list of the 10 last commits that have been modified and you have access to. So if you're looking for like the last one that you just updated, like this one, you can just click here, or we could search for symmetrical palace in the search bar, which works again also with GraphQL queries. And once we actually select it, this will take us to the side-by-side kind of viewer setup that basically each one is linked to one commit. So we need to specify from the commit history. In this case, the history is very small. It just has 2 commits. But as it spans in time, hopefully you will have several dozen commits in place. So in this case, I'm just going to select the latest commit that I've been doing. And as you can see, it's already loading it in this half, which is the one that is missing the stuff. You can actually, it will actually display the message and the author and the authoring application. So you can actually distinguish one from the other. And then we can select the second commit, which it automatically grays out the first commit that you selected, just to not compare the same thing against itself. Whoop, should have not had breakpoints there. Wait a second. Aha, there you go. And basically this will load up the second view, and you can see that they're slightly different. So now that we've actually loaded the second view, what has happened is that the front-end app has asked our backend if there was already a diff commit that existed between these 2 uniquely identified commits. And since it didn't, because it's a fresh new output, what we're seeing is this request diff button, which is gonna call our server again, our backend, to start this operation of pulling the data from the 2 commits, comparing all of the objects against each other, and committing to a branch called diff that will have the actual result commit in it. So let's just hit it. And this may take, depending on your commit, couple seconds, a while, it depends. The heavier your commit, the longer it will actually take to do so. But hopefully, if everything goes well, yes, comparing meshes, it's doing its thing. We will do the code walkthrough, so everything will make more sense code-wise. But okay, diffing was successful, sending to Speckle. So it is doing its thing. It's just taking a second. And once it's actually finished doing its process, it will return the actual commit object of the new diff that we've created. We can check this out. Sorry for the messy desktop organization. There you go. We could actually check this out in our stream.
I think maybe I have to refresh.
Yeah, I think that
for branches.
Hard reload for branches,
yep.
Yes. And now we have, not only we have our main branch, which is the branch where I send my 2 commits, I also have a new diff branch, which contains, as a message, it contains the 2 commit IDs that we compared. So this weird number dash this other weird number. And it was actually created by me. So we are actually authenticating in both sides of the app, in the front end and the server, to impersonate ourselves. And this should display our differences. Somehow removing the door did some weird stuff in the wall diff. But as you can see here, we now have all of our furniture marked as changed. So you can actually inspect all of the details of the geometry that has changed and the details of the geometry that was originally there. But also, if you go into the commit itself, you will see that we have a list of same elements that are the elements that remain exactly the same, a list of references, and the list of changed objects that appeared, that have been modified in our scene. So everything is kind of like the result is tightly coupled into all of the data that has been created. So you can actually distinguish programmatically which is which, and which one comes from commit A, which one comes from commit B, etc. To be able to further extend it in the future if necessary, or do further operations that are not strictly this operation. But as you can see, everything gets stored in Speckle itself. So the actual app doesn't really use any database to actually store anything. We're just pushing things to Speckle and receiving things from Speckle in different branches. And then once that is done, we will have this view diff button here that basically flips the side-by-side viewer of the 2 commits to the full view diff commit. Hopefully that makes sense and allows you to go back and forth between them. So the actual functionality of the app is quite simple to allow us to keep it short and sweet. And we can go deeper, as deep as we need in the questions and answers, of course. But basically, that was the whole demo. Hopefully it didn't take too long to do. Am I missing something, Claire?
No, I think that was everything. We'll show at the end, like you can actually receive the diff branch and receive those objects just like you would any other commit, and get it back into any other application to use for a modeling assistance. Yeah, you can just show
that directly
in Rhino.
I'm just gonna open Rhino and Speckle. So as you can see, the Rhino Speckle UI is exactly the same as the Revit Speckle UI. It's just like slightly tailored to the platform. So you will see that if you use the Rhino UI, you will see that the filters that we offer for Rhino are different from the filters that we offer for Revit, because it does make sense to have like tailored approaches for each authoring platform, but the most of it remains as it is. So in order to receive something from another application, the same way we added a stream in Revit to send, now we can add a stream, since we get the latest streams in this quick list, I can just directly click this blue arrow and add the Symmetrical Palace stream to my I would say it to my Rhino file. And since it's already contained a commit, originally when we created this one, it was already kind of like in send mode because we had just created a stream and it had no commits in it. So obviously what you wanted to do was to send, but once you add a stream that already has some commits in it, it comes in receive mode. You can always switch one to another with these arrows in the corner. So you can switch it from a send mode to receive mode without actually reconfiguring anything. But just know that once you add an existing stream, you will automatically get it in receive mode. And in this case, we don't want to receive from the main branch. We want to actually receive the diff commit. And this also allows you to specify if you want to receive always the latest commit in a branch, or you want to receive a specific point in history on that branch. No? In this case, we want the latest one. It doesn't really matter, but we can receive that. And fingers crossed, our demo will work as expected and everything will be beautiful. We do have some warnings. Failed to bake. Oh, maybe it didn't work as beautifully as we expected. Let me see those layers. Okay. Okay, I think the colors got lost somewhere on the way. What am I doing there? But ideally,
you can write.
Shade it.
Yeah.
Aha, there you go. There you go. So there you have it. That's our mesh geometry that was compared and all nicely colored and separated in different branches. So you can actually see just the objects that changed.
If you expand the changed layer, you should be able, so when we detect, as before, the base objects come with an application ID. If the objects have the same application ID, it'll know to pair those objects and compare those directly. So when you receive the diff mesh in Rhino, all of the changed objects will come paired with the one that you were analyzing and the object they were compared against.
Let me see if I can actually find the biggest object of all. Yeah. There you go. So that would be the actual change sofa and the reference sofa. So you can actually have both in the same place at the same time, let's say. Obviously, there's already a lot happening, but once you're talking to the Speckle server, you have access to all of this information, their IDs, their metadata, etc. That right now in Rhino, there's some data loss as far as I'm aware, depending on how you add your metadata. But in this case, we are preserving most of the structure, the layers, the references, etc. So as you can see, there's a lot of possibilities in this type of workflows and automation-wise that may not be strictly diff related. But that being said, that was our demo. There you go. It worked. I am amazed.
So I guess we can field some questions now, if there are any, and then take a little bit of a break before getting into the code walkthrough. Yeah. Has anyone tried cloning the repo and building? Has anyone had any issues installing our Python SDK or other pieces for the walkthrough?
Or any other random questions that you have in your mind lurking? I guess, are you pushing parameters to the Rhino objects? Okay, let's go one by one. Eric, the parameter, when you push from Rhino to Speckle, like from Revit to Speckle, all of those parameters are preserved in Speckle, but it depends on how you what authoring platform you receive them on. You may, for example, in Revit, if I remember correctly, if you receive them in Rhino, you will only get the geometry, but most of that extra metadata gets lost. If you receive them in Grasshopper, since you have way more power over how to manage the data in Grasshopper, you receive the whole package, all of the parameters, all of the meshes, everything. So it really depends on the actual platform that you're sending from. In this case, Revit, we do preserve everything or most of the data that we can to Speckle. And then when you receive it in a specific authoring platform that is not BIM enabled, let's say, then the objects will be dumped down to be compatible with that specific platform. Hopefully that answers your question.
And the second one, a slider change in Grasshopper. We've been getting pinged with Hypar/Speckle integration for a while. Currently, we don't. Our Grasshopper connector currently doesn't have. We don't have like a script-based object yet that may or may not be on our roadmap in the future. But of course, if you have a slider and you change the value and create a new commit, it will track value changes in the actual objects that you're sending to Speckle. But currently, we don't have a way of, for instance, like saving components.
But so basically what you're sending is whatever you plug into the sender node. So you're not sending like your Grasshopper definition, you're sending the result of your Grasshopper definition. If that is BREPs or meshes or base objects, that is what will get sent. You can organize it as you will, but there's no like parametric computation fanciness yet. We have had some questions about this, so I may link in a bit. Once I have the break, I will try to find them in the forum and link them up here, so you can kind of like peek into the previous conversations and see if that solves some of your itchings.
And yeah, I think an unexpected perk of our Revit connector is being able to downgrade Revit models through Speckle. But
up to a point.
yeah. But yeah, generally our connector, like the fidelity of the conversions in our connectors are really just limited to the like native applications APIs. So like for instance, if you create a ceiling in like 2019, because the API for Revit 2019 doesn't support native ceiling creation, once you send that ceiling to Speckle, you can't receive it back in 2019. But since 2022, for Revit, their API finally allows ceiling creation, then you can receive it in Revit 2022, for instance. So a lot of the converters and the conversions are limited by what you can achieve through the application APIs.
Yeah.
But whatever can be preserved will be preserved.
Yeah, and as for the native geometry to be restored in Revit from previous versions, I would add an asterisk there, a very, very big asterisk, because even when it depends, it also depends if the geometry already exists in your model when you're receiving it back, and what type of geometry in Revit that is. So it's like a complicated question. The answer, as Claire said, is like we do our best, but there are limitations. But also if there's stuff that you would like to have and you don't see, do ask away in our community forum, because sometimes there's things that are not doable, but sometimes it's just things that we haven't gotten to do. So there's a limbo there that we can play with and implement nice additions if possible.
We always welcome people to make contributions to our repo for specific conversions. It's a lot to kind of get your head around the whole ecosystem around the Speckle Sharp repo, and it's a monorepo that holds all of the like C# connectors. And yeah, we're constantly improving our conversions. Like we're constantly adding new objects that we support across our connectors. And if you yell at us hard enough on our forums, we will most likely start supporting. Recently, the most recent one is in our civil applications with clothoid curves. So yeah, we're very responsive on the forums. And if there's a specific element that isn't currently supported, we will do our best to add it ASAP when people need it.
Yeah, clothoid curves are another thing that are not really supported in Rhino, so we have to.
Yeah.
There's tricks and magic happening on the background, but we will support it in some way. Yeah. We always kind of send, which I'm not sure. I think you commented it on the presentation. We always send all of our objects with some sort of display value as a fallback. So every single NURBS curve or smooth curve is sent alongside with a polyline to display it in wherever is not supported. And we do the same with solids. If you send like a very smooth, complex BREP from Rhino, it will also be sent alongside with its mesh representation to be able to display it in the viewer, but also display it anywhere else that does not support BREPs, which is most of the software that we target in some way or another. So you always have like this, when you're using Speckle, you always have like this fallback value that you will always be able to receive the geometry, even if it incurs in some kind of like data loss or geometry precision loss. But obviously, if it's not supported on the platform, you better have some precision loss and end up with the object than end up with no object at all, no? At least that is our view. And not sure if we have any more questions. I haven't checked Slack in case anybody dumped anything there. No, doesn't look like it.
Maybe we can take a quick break and then come back and go through the code.
Yeah, start opening geeky files and see what's happening. Okay, well, let's do a 10-minute break maximum. Let's meet in literally 8 to 10 minutes and we can start going through the whole thing. We have a couple more questions. Look at that.
Yeah. So when you when you receive geometry like Speckle objects from a different from an application that's different from your authoring software, you are actually creating, like Speckle is actually creating new instances of that geometry or object in the receiving application. So it'll get a new application ID natively, for instance, in Rhino in this case. So for instance, say you send a wall in Revit, that wall will come, as Alan just mentioned, with a display mesh, which is what we're using to render in our viewer and web platform. When you receive it in Rhino, because Rhino doesn't have a wall class, it will default to the display mesh. And as you saw in the demo, instead, what will happen on the back end is a mesh will be created from the wall's display mesh in Rhino. And if you edit that mesh and send it back to Speckle, it's a completely new object at that point. It won't know that it came attached to a wall. However, we have slowly improved our Rhino to Revit workflow. So we have a Rhino BIM Speckle section to our connector. And what that allows you to do is if you want to, say, have a dimensional control model in Rhino where you're just modeling surfaces, but you want to send those as walls to Revit, you can attach a Revit wall schema to your Rhino surface. And when you send that surface to Speckle and receive it back in Revit, then it will look for, does this have a schema attached, a built element schema attached to it or not? If it finds the wall, it'll try to convert that as a wall in Revit. So we have, in certain cases, improved that workflow.
Yeah, But
But
most
if
of
you
the
receive it
time,
in Grasshopper, again, you'll get all of the objects. So you receive the wall in Grasshopper, you'll get all of the properties. If you change any values and send it back, it'll still have the application ID attached, and you can update parameters directly through Grasshopper. So again, anyone who knows Grasshopper, it does make life a lot easier.
yeah, same with Dynamo, although our Dynamo connector is a little bit less used than the Grasshopper one, as far as I'm aware, but it's kind of like a one-on-one equivalent. So if you're more of a Dynamo person, you can also do all of your kind of automation and receiving and doing Revit stuff in Dynamo through Speckle to do more advanced receive operations than the default behavior of the Revit connector. No? So that's basically why we target Grasshopper and Dynamo, is because we are aware that sometimes the actual behavior of the receive button in your application doesn't really cut it for some specific customizable reason. And then you can just use Grasshopper or Dynamo to bridge the gap between the data that we extracted and saved in Speckle and the actual thing that happens in Rhino or Revit. No? And that being said, we do have ways of updating specific parameters from Grasshopper directly in Revit without actually sending geometry or anything else, just specifying like the ID, the parameter, and the value. So there's a couple of like Revit specific workflows that we do target. But Revit is a complicated beast, so not everything works as smoothly as we would wish. We're always open to suggestions and complaints too. And can the Speckle Manager be installed in another path than the user's app data? As far as I'm aware, no, not at this moment, but do explain further. Why would you need that? Are you working on a corporate computer or a work shared virtual machine or something? Because we've had some users with some trouble there, but I'm not aware of the actual solution. We can find it out in the server for you. Okay. Yeah. Well, if you want, if you're having trouble with that, ping us or drop us an image or something in the community forum. And it's something that we do really want to kind of solve, at least as much as our side allows us to solve it, to make your life easier for corporate computers, computers with restrictions, places you're not the admin for, etc., to work nicely with Speckle. And there's a lot of edge cases involved in these scenarios for each individual company and how they set things up. So we're really, really interested, Bob, in knowing exactly what's failing. And if we can fix it, we will definitely fix it. So please do send us a message to Slack with some screenshots, and we will look at it. Not today for sure, but at some point soon.
All right. I guess we can do a 5 to 10 minute break. I'm just going to link that stream from the demo in Slack.
Awesome.
I mean, in here as well, in case anyone wants to explore the front end, browse the data, inspect the data. But yeah, I guess we'll reconvene maybe
in
quarter
past. Yeah, let's do quarter past. Okay, see you in a bit.
All right, we're back.
Okay, let's do this. Let me see if I can share my screen. I will kind of start from the beginning and walk my way through the structure of the app, how it's set up, why it's set up the way it's set up, etc. Hopefully you can all see my screen with the Speckle guide website in it. If I shared the correct one, please let me know if I didn't. Clear?
Yeah.
Okay, let's do this. So let's start from the beginning. Most of the stuff that we just explained, it's explained in even more detail in our Speckle guide, speckle.guide website. If you go to the website, you will land to our user guide, which explains most of the Speckle manager, connectors, all of the things that involve the end users, the people that will be using Speckle in Revit, in Rhino, etc. This also includes guides for the more advanced connectors like Grasshopper, and even includes some even more advanced features like how to use Speckle in your C# and Python scripts in Grasshopper. I think there was a question that we didn't answer before about IronPython and SpecklePy playing together. And as far as I'm aware, they won't play nice together, but you can use the C# SDK in IronPython, and they are basically a one-on-one. Like they have the same methods in the same structure, same everything. We've made it as similar as possible, so it shouldn't really make a difference. I just wanted to show this to answer the question. In this case, you would just add your references to the Speckle Sharp DLLs in your IronPython script using CLR, and then you can just import as you import in Python anything else, and use the base object, add properties, etc. So you kind of can make it work, but you won't be able to make it work with SpecklePy. It has to be with the C# version, because IronPython likes C# better than some Python packages itself. And so once we actually get to the guide, most of the app-related stuff is explained in the last section of the developer docs, which is the create your own app. Here we're basically, today, due to time restrictions, we've already given you like a pre-cooked app that already contains everything. So we're not gonna start from zero, like from a bare bones application. If you do want to see how that process is done and all of the different minor parts involved in it, we are going to explain the overall structure and how everything plays together, and we will code the Speckle specific parts, but most of the Vue.js parts we're just gonna skip, because it's less interesting to spend time there than actually explaining the core Speckle concepts. If you have any questions, we are happy to answer them too. It's just we want to keep it as short and sweet as possible. So feel free to go here into create your own app and check this one out. The app that we're doing follows kind of to the letter this structure. So we're still using the router, we're still using the same structure for our queries, same files, everything. So it should be applicable. So if you want to, once we finished our masterclass, if you want to know more about the details and setting up your own app from scratch with what you've learned here and this guide, you should be good to go. And with that said, let's actually get to the bottom of it. Let me find my Visual Studio Code somewhere here. So in our Visual Studio Code folder, we downloaded the repo and opened it up. I'm currently in the main branch, which should be the branch that you all get if you cloned the repo directly. We also have a Masterclass/start branch, which is the one that is missing some of the code to follow through during the class. But for now, I'm just going to keep it in the main. I'm just going to explain the core stuff in the main branch. And once we get to the coding, I will switch to the other one just to have everything ready to get started. So the app is basically divided into two main folders, the front end and the server. There's a couple of extra configuration files like the vector config.js, which is specifically for this plugin, this Vue plugin called Vector in Visual Studio Code, which we recommend you using. It is a must if you're doing Vue apps in Visual Studio Code. So we added the config so you would already have everything sort of ready to roll. If you're having any problems, do let us know. And then the front-end app contains all of the web-related things that you will see in Chrome. So the actual website, the actual buttons, the viewer, etc. And the server is a fast API server. For the ones that are not familiar with Python, fast API is a Python-based REST
It's like
server.
a framework. It's a web framework for building APIs. Yeah.
It's exactly the word that I was looking for.
And we're using Unicorn, which is our server implementation, and they're all. It was so fast to get set up. It was just a couple of minutes.
It's quite stupid. If you like Python, it's quite stupid to get started with fast API because it basically requires 2 pip install commands. That obviously you need Python installed in your computer, etc. But once you have that, you just need to run this command and then this command, and basically you're ready to go. You follow to the letter their guide, and it should get you going. It's basically the same structure that we have with a little extra stuff to make it play nice with our front end. But it's basically just a way to create get, post, delete endpoints in your server, and then just program some functions to happen when those endpoints are hit, in this case by our front-end app. So let's kind of get that going. If you open, let's start with the server. If you open your main.py file, you will find there's a bunch of imports. The 3 first imports are, the first import is the OS library from Python, which is pretty standard. We're using that to get some environment variables that you can use later on to deploy your server, your application, and talk to different Speckle servers. But in this case, we are talking directly to speckle.xyz. If you haven't got an account yet, please go and do so. You should be able to where am I? I got lost. Log out.
This is our public community server. Yeah.
Exactly. This is our public community server. It's totally free to use. We don't guarantee that your data will live there forever, though. But it's a good place to use as a playground and just like randomly push stuff and test Speckle without having to commit to deploying your own server or asking us to deploy a server for you. And this will basically, we're never gonna kill this service, but the database may or may not be deleted at some point. So don't rely on this for live, real projects. If you do use Speckle for real projects and you have any problem, do contact us to guide you through deploying your own server and having your own infrastructure in place, so you don't depend on us for your data to live forever. You can depend on yourselves. Well, with that said, you can log in with Google in our specific server. I'm going to use my Speckle account. And in this server, if you go to your profile page, you will see the section of your actual data, which is pretty minimal. The data that we actually collect from you guys is a company, email, a description, picture. That's basically it. You have a section for your apps, which are the apps that have actually requested access and you have granted access to. And at any point in time, you can revoke the access to that app so we won't have access to your data. So you have total control over who and what and when your data is being accessed. And then if you scroll further down, you go to the section of the personal access tokens, which is a way to very quickly get running with API calls instead of using OAuth to authenticate with different users. But in this case, we're actually going to build an app. So we're going to scroll down forward this one and go to applications, which is the place where you can actually create your very own Speckle integrations. And this is pretty straightforward to do. You just need to create the new app. As you can see, I already have a bunch load of stuff, but yours should be quite empty. And I'm just gonna call it AECtech Masterclass app. And this will ask you to specify some scopes. Scopes are the different sets of data that your app is allowed to use. So you may actually allow an app to read streams, but not write them. So even for any user, even if you have access to write them, you won't be able to write them through the app if you don't grant the user permission. In this case, since we are going to be wanting to send some data to Speckle, we're gonna also allow the streams write scope to be able to send some data to Speckle also. We're also gonna allow the app to read your profile, meaning all of this information that we saw above, your picture, your name, your company, so we can actually populate your user profile in our app. And just for the sake of it, I'm gonna click email. And in this case, we're not gonna be searching for users, so we don't need the users read functionality. And none of you are going to be the administrator of the server, and we're not going to be using server statistics like usage, new number of commits created, etc., which we do collect in each individual server, but you need to be an admin to request. No? So in this case, these two, we're just going to forget about them. And then it will ask you for a redirect URL, which is the place where you want your app to send you after you've accepted the app as to access your data. No, remember when we let me just log out of there. When you logged in, we sent you to this page in the Speckle XYZ server, and then when you hit allow, this will redirect you to a specific URL. No? In this case, since we're gonna all be working locally, we're gonna be using http://localhost 8080. This is the default port for a Vue application, and most front-end framework applications use 8080 for development. So we're gonna use this as our URL to be sent back. And I will explain the whole authentication process once we have actually done this. And I'll just write that this is the class demo app. There you go. So once I save this, you will get this panel, and you will get these two pieces of information, the app ID and the app secret. So you need to copy both of these guys, and we will use them later on. You can always access them later in the details of your app. So it's not something that gets lost forever. You don't need to copy them right now, but we will use them in our app. This is part of the process of authenticating through our app. We need to provide these two pieces of information to basically tell the server that we know that this app exists and we want to authenticate through it. No? And in order to do so, here you have a very nice note, which is part of what we're going to code live in a minute. It tells you that you need to direct your users in order to authenticate through this app. You need to send your users to this specific URL, which is speckle.xyz/authn/verify. Can I zoom that in? There you go. /my app ID and /a challenge. Which if somebody hasn't done OAuth before, it may sound super weird, but this challenge thing is just like a random string that we're gonna generate and save. And it basically is in order to check that once you've sent the user to the Speckle SYZ and he comes back, you can actually ensure that it is the same user in the same computer and that nobody is trying to kind of like fish your authentication data to hack your way through the server. No? So it's a very secure way of authenticating through a platform. Let me just remove that back to 100%. So once we have this app done, this is basically all of the setup that we need to do on the Speckle server to get our app up and running. The rest of the actual part is all done through coding and through routing through Chrome. So let's continue a little bit more on the Speckle server side. We basically, as I was saying, we have this server URL, diff branch name, and front-end URL variables to basically tell the server where is our front end located, where is our Speckle server located, and what is the branch that we want to send the diff commits to called. No? So in case it needs to create it or find it, we are hard coding that value into our app. So it's basically always going to be that same application. Then we have this chunk here, which is about course security. I won't go very much through it because I'm not the expert in this subject. It's basically an extra security layer on web communication protocols that require you to specify what are the allowed kind of web pages that are allowed to talk to your server. So in this case, since our server is located at localhost, our front end is going to be located at localhost 8080, we're basically allowing localhost to talk to our server, and we're using this configuration, which is basically allow everything. This is not very secure, by the way, but we just did it to keep things simple and not add too extra code to it. If you really want to deploy something, you should enforce better security than just allowing everyone to talk to it. But that's a different topic for a different time. And then we have these two functions here. Let me just fold them down to see them better. We have this get diff function and get diff check function. Basically, what this does, it sets up a couple of endpoints in your server. One would be your server URL /diff / your stream ID / your commit, the current commit that you want to compare with, and / the previous commit that you want to compare it as an ID. So basically, we're passing all of the information that we need to operate and to create the diff directly in the URL to keep things as simple as possible. And then this get diff function basically gets these three different inputs that are strings, and in essence checks if you are sending an authorization token, which we will talk about in a minute once we do the front end, and create the actual diff, which is done by this class called Speckle mesh diff, which lives in meshdiff.py. I will go through this in a second. So basically, if everything goes well, we return an object, which is going to be a JSON object, which a single, let me zoom that up. Oh, too much. There you go, better. With a single property called commit, and inside that property, we have the actual diff commit object that we generated. And if something went wrong and we didn't actually manage to send the diff commit, what we will send is a 500 error, which means that something happened in the server that prevented the operation from going successfully. It's just a way to notify our front end that something went wrong. You know? It's as simple as possible. And then we have the diff check, which basically does the same operation. It's practically the same code, but instead of calling this process diff function, it calls check existing commits function. And if it does exist, it will return it. And if it doesn't exist, it will return a none or a null value. So you can actually operate accordingly in our app. This is what we're going to use to, yeah, sorry.
Yeah, this is just to explain a little bit. This is just to help them performance a little bit. So on the front end, if you've already compared one commit against another, that would generate a new commit in the diff branch, and you don't want to waste that effort. And the next time, if someone wants to compare the same two original commits, instead of running that whole thing again, because each commit ID is unique, we can, and we're including that as the comments to the diff branch commits. We can always search through all of the commits in the diff branch, search through their comments, and see, did we already compare the two commits that the user selected? If it was already compared, it will just return the existing commit on the diff branch rather than recomputing all of the differences again. So this is just a kind of like a luxury endpoint to improve the performance of our front end app.
Yeah. If not, you will have to always compute the commit. And if it's like an entire building and you already computed it, but it's a little bit of a waste of computing power. So you might as well just return the previous one. So let's actually, once this is explained, this is fairly straightforward. It's just a server with two endpoints, one to actually perform the commit and another one to check if that commit exists in the diff branch, you know? So how do we pull this off? No, if we go to the mesh diff class, basically it's a normal Python class. It doesn't inherit from anything. It's just like a pure, dead simple implementation. Let me just fold this up nicely so we can see the whole thing. There you go. So we just have three specific like instance method, and then everything else is a static method that doesn't require the actual class to be instantiated to run. It's just like we would just use it as a place to keep all the functionality like kind of under the same hood and keep things as simple as possible. So the process, let's do the simple one. The check existing commits, what it's basically going to do is it's gonna use our Speckle client, which I will talk to about in a second. And it's basically gonna try to find the diff branch that we specified, which in this case is very aptly named diff. And for all of the commits, or at least all of the commits that we fetched, because we're only fetching a maximum of 50, we haven't done any extra pagination fanciness or deep search. To keep things code-wise as simple as possible. So basically, we're just iterating through the entire commits and checking if the message is equals to the current commit dash the commit previous, which as you saw when we did the demo, that was like the pattern on the commit message that we were using to keep track of that specific comparison. So if that commit exists, we actually return that commit. And if we don't find anything, we return none. It's a very simple kind of like approach where all of the main problematic is being dealt with by Speckle in its own branches. And you're just basically doing a loop and searching for a specific information in that commit that you created to ensure that it exists or not. As always, if anybody has any questions or wants to stop me for a minute, do say so. I'll be happy to go slower or faster if necessary. Then we also have the process diff, which is the other kind of like big main entry point. And what this does is a little bit more complex. And I try to split it down into its different parts so it would be clearer to understand. Basically, what it's doing, it's first it's assigning the stream ID, commit current, and commit previous to the class properties to be able to recycle them throughout the rest of the methods. And we're receiving the previous commit data and extracting all of the messages from the previous commit. This is done by basically iterating through the whole object and checking if something is a mess or something has a display mesh in it and returning everything that we can find. It's pretty straightforward approach. And then we do exactly the same operation for the current commit. So we basically, once we want to start a diff, the first thing that we do is kind of process the data that existed in Speckle, grab everything down to our server, and extract all of the geometries that we want to compare from it into previous meshes and current meshes. And then we just run this super complex behavior that if you have any questions about it, Claire could answer everything because she is the magician behind it. And it basically, you give it two lists of meshes, of speckled meshes, and it will compare them first by their ID, and if the ID, I will say it first by the ID and then by vertex, no?
So conceptually, because we're leveraging the fact that everything that you're sending to Speckle has an ID and an application ID. So because the ID is generated from a hash of the whole object, if the object hasn't changed, it's coming from the same application, it has exactly the same properties, including additional properties when you send it from Revit, like parameters, etc. The hash will be the same. So automatically, to make the algorithm more efficient, you can ignore everything with the same, that has the same ID between the two commits. The second thing is, if something has changed, say the name of an object has changed, but the geometry hasn't, but it's being sent from the same application, you haven't deleted the object, you've just moved it, rotated it, scaled it for geometry changes, or you've changed some non-geometric properties, then the application ID will remain the same, but the hash will be different. So first, we're removing everything with the same ID, and then we're trying to find all pairs of same application ID. And then within the application ID pairs, it'll do more sophisticated diffing, where it cares about the geometry but not about the other properties. And since we developed this very quickly in like a day or two, the logic is very rudimentary, but of course this is something you can always hack and refine the logic under the hood to create more sophisticated diffing if you want to display changes in properties, changes in other non-geometric values, etc. So
yeah, and then basically once we actually get that diff object, which contains all of the objects that you saw on the demo, organized by the ones that are the references, the ones that are the same, and the ones that are different with its pairs of data to link them together, we basically call the send data function, which requires a Speckle client, which is instantiated when we instantiate the class. And basically, what it does, it's gets all the branches from a specific commit and from a specific stream. It checks if the diff branch that we want to send to exists, and if it doesn't, it actually creates it with a nice description to explain that this was automatically created. And then, as Claire explained, we use the server, and in the presentation, we use the concept of transports to send data to different places, not only the Speckle server, but in order to send to the Spectral server, you need to create this thing called Spectral Transport. This is the same in Python and in C#. It's same exact class. So it basically, it requires a client, which is the one that has the authentication and knows how to connect to Speckle, and a stream ID to tell it exactly to what stream you're going to send to. And then you can call operation send with the base object that you want to send, which is the diff object that we were passing in somewhere. I lost myself right now. Where is my diff object coming from? Here. We're passing in in the input as a base object, and the transports, which is a list, because you can send to multiple servers at once if you have if you wanted to kind of like duplicate your data or send data simultaneously to various places. In this case, we just have one transport, the server transport for XYZ. So we just create a list of one to it. Operations.send is part of the Python SDK. So it's just a super straightforward one call kind of deal. And then once you've actually created that object, you need to create a commit for that object. Like this is a when you're dealing with the connectors, this is done for you. But when you're dealing with the code part of the SDKs, you do need to first create an object, get the object ID of that object that you just created, and then create a commit using the stream ID, the object ID, the branch that that commit belongs to, and a specific message. No? So this is where the commit data goes, and then this has a reference to the actual data that you sent as an object ID. I will go through the API in a second once we finish with this, so we can actually play a little bit with the GraphQL queries and see the references and how this actually plays along. And then we also have the receive data function, which is the other one that kind of bears importance to note, which basically uses the same concept. You have to create a server transport with the client and the stream ID. And then you kind of like try to get that commit, and that commit will have a referenced object. In the same way we added an object ID when we created a commit, when you receive a commit, that commit will have that ID attached to it. So you can receive that commit using the reference object and the transport. And that's basically all that it takes to actually receive something using the SDK in Python. Once you've actually received it, then comes the complicated part of the meshes, etc., which I'm kind of gonna skip due to time restrictions. Yes, we're 1 hour, 10 minutes to the deadline. So if you have any questions about how all of this actually happens, we can go through them after the main demo, but I'm gonna skip the actual geometric magic behind all of this and just stay in the Speckle realm at this point. So basically that's basically it. We just have some receive data function, send data function to operate quickly with it. And we use that to catch all of the data that we sent, do our operation. That operation could be comparing meshes or anything else. No, it doesn't really restrict to a geometric operation. You could do some analysis as we did for the carbon application, and then you send the data to get that actual commit ID. And finally, since our application actually requires those commit objects to function properly, we actually do fetch that commit object entirely and send it back. So this is kind of like the main logic of a Speckle operation. In this case, it's going to be a diff, but in your case, it could be basically anything that you wanted. You always need to kind of like receive some data, do some operation, and if you want, you can always send it back to Speckle, to the same branch or a different one. Oh yeah, I missed the init. So basically, when we construct the class, this is where we construct the Speckle client, which is a specific class in SpecklePy API.client. And once we have the client, you need to call authenticate and pass it a token. And as we explained during the presentation, the token is basically a very special password that identifies you as you. So you don't need any, if you pass the token, you don't really need anything else to operate as for the server to operate as yourself on Speckle. So do be very careful with your tokens and don't commit them to Git by any means. Try to not make them public. If you do, you can always refresh them, but just a security note. And that's basically all of the logic behind the Python server. We have our diff checking that just basically fetches some data like fetches the commits from a branch and checks their message for a specific pattern. And we have the process diff, which fetches 2 commits, does an operation with both of them, and outputs the result back to Speckle on a different branch. And that's about all that is involved in the Speckle world. So at the end of the day, it's kind of like, what, 20 lines of code, really, the actual Speckle operations without going into the specifics of any app. And then once we have our server running, it would be worth noting that the actual command to run the server is in the Fast API installation. So if you're following along and you want to actually get the server running, you can either run this command, and maybe Claire can post it in the chat because I lost my chat somewhere in the many windows I have open. And and that should basically, you just have to paste that into a terminal and you should see.
We'll run it in the server folder of the local Masterclass repo, because it's looking for that main.py.
Yeah, so basically if you open a terminal in Visual Studio Code, it will open in the root of your folder, so where the README is basically, but the actual server is one step down in the server folder. So we will need to cd to the server and then run this command, and you should see your Ubiquan running on X, started reload, application startup complete. And if we actually, oh, what did I do wrong? Command click. If you actually go there, since we only have 2 endpoints, there's no real entry point to our website, to our server. No, there's just like a not found error. But if you actually go to /docs, Fast API has a fantastic automatic documentation thing that also allows you to kind of like check the different inputs, outputs that it uses, check for responses, etc. So it's kind of like a very neat framework to work with because it documents and creates your server in like the minimum amount of lines. But our actual diff endpoints, if we actually were to use them, diff.whatever /whatever ID /whatever ID2, it's actually working because it's giving us no token provided error, which is, if I get to myself, the error that we send when we don't authenticate our communications, which we will do now in the front end, and it will definitely work, hopefully. So that's basically it for the server for now. We will go back in a little bit to test everything once it's actually running. But originally, if you just run that command and you get an all okay, this is all that we need for now for the server side. And I'm just gonna open another terminal on the side for my front end. So my front end is a Vue app. Vue apps, if anybody's not very familiar with Vue or JavaScript front ends in general, are very heavily structured in a very specific way. Not that it requires you to do so, it's just the templates come in a super specific structure, which helps a lot because everything is always in the same place for all of your Vue apps. So it's kind of neat, but if you're not used to it, it's also weird. So let me walk you.
It's nice because the Vue components, as they're called, they contain, each component has an HTML, CSS, and JS section to it. So yeah, they're kind of very convenient building blocks once you get familiar with passing information and triggering events from component to component.
Yeah. Most of that we've already pre-hooked to not have to go through the complications of Vue itself. And we're just going to concentrate on explaining a little bit the structure, explaining the meaning of everything, and then going through the actual authentication to the server, doing some queries to the Speckle server, and the actual Speckle specific bones, no, let's call them. So in our apps, in our Speckle View app, you will find a set of files. Firstly, you will find this app.view, which is the main view component for the application. And this is where the navigation sidebar actually lives, the top blue bar that we saw before, with the login buttons, the user image, the search bar, the app name, etc. And it also contains this router view thing, which is the thing that renders each of the different pages. So when you go to your website, it will show you the home page. If you go to /streams, it will show you the stream page, etc. So this is basically where all of that magic happens. This is a very view specific thing, but other frameworks have their own way of dealing with this, no? So this is basically all that we're going to be looking at this. I will explain a little bit how everything works in the background. So from our app, we also have our main.js file, which is basically the entry point for all of the JavaScript view application. And this is where we're setting up our view application with the router, which is the plugin in charge of changing pages in your application, the store, which is the plugin in charge of saving data that is global to your entire application. We're going to use that to store the user object, to check if the user is authenticated, and to store the server information, just in case we need it for anything else, which I think we're not really using that in this particular example, but we could. And then we're also using Beautify. Beautify is a fantastic framework built on top of Vue. So it's basically, for the ones who are more familiar in web design, there's this material design library that is widely used. I think it was developed by Google. And it's basically a set of neat components and features, including grids, layouts, but also things like alerts and CSS cards, like all of the actual hard work of having like nice buttons, doing nice things like pop-ups, having dividers, etc. No, there's like an infinite amount of things here. So we use, and especially in Speckle, we use Beautify a lot. You could use whatever other framework you wanted, but this is the one that we chose, and you will see that the demo relies heavily on using Beautify components to simplify the actual amount of HTML that we need to write to pull all of this app together. So with that said, let's get started with the actual explanation of the parts. We've just gone through the main files. Then you will see the Speckle queries and Speckle utils file, which we will code part of it, but if you don't want to code along, you can just stay in this branch. Everything is already implemented here. And this is basically in charge of all of the Speckle communication regarding saving the tokens into our local storage to keep them in the session, logging out when the user clicks the logout button, exchanging the access code when you're doing the login process, etc. So there's a lot going on here, but hopefully by the end of the hour, most of this would be clear enough. And then we have the Speckle queries, which are actually the GraphQL queries that we're using to get the data. I will go through the API backend in a second. We also have the views folder, which is where our three main views will live. We have an initial view, which is the home view with all of the stream list. We have a stream view, which is the one with the side-by-side viewer and the diff viewer and the top control bar for selecting the commits. And then we have a very simple, pure HTML login page, which is where everybody ends up when you're not logged in to the website. So you have to physically log in to be able to have access, no? And the app will do its best to prevent you from doing that. And then we have a couple of components, which most of them I'm not really gonna touch much in detail. In the viewer folder, you will find all of the viewer related components. This includes the renderer, which is the main viewer component that we created. We're gonna skip the explanation of this because most of this would be obsolete in like 2 weeks, 3 weeks maximum when we release a new viewer version. But most of it would kind of sort of remain more or less the same. So you can see here how you can set up the different interactions to, for example, change views, change camera actions, react to selection events in your model, etc. So if you're curious to see how exactly this happens, feel free to jump in here. Most of it is pure JavaScript calls to specific functions in our viewer package. No? For example, all of the interactions are under the interaction objects. We can also listen to selection object, selection events, etc. So feel free to jump in there if you're curious. And then all of the others are basically handy components to display the data when an object is selected. So you can actually see that data in a nice pop-up view. We will show you this in a minute once we have it running. And then we have the commit selector, which is the main bar that we were using to select the different commits and to do the request diff, etc., which we will be coding just a little bit in here. The most important part is the actual commit panel, which is the one that does all of the magic. And it basically, the most important things are the two methods that we're gonna code if we have time today, which is the does diff exist method and the request diff method that are basically going to talk to our backend, the fast API server, and get some responses from it. Everything else is very view specific to kind of like communicate events to the different views and update different values whenever they change, so we can actually keep everything nicely updated. But the actual app related part is just these two functions inside our commit panel .view. What else am I missing to explain on the overview? Oh yes, important. You will also find the router and the store folders. As I said before, the router is the one in charge of all of the different pages in your website, let's say. And this is, if you open this, you will see that you have a routes list that basically configures the different paths of your application. So if you go to yourapplication.com/, if the view application will serve you the home component, which we saw in the views folder, this home.view. If you go to /login, it will show you the welcome view. And if you go to /streams/ a specific ID of a stream, it will, if that stream exists, show you the commits for that stream and send you to the stream view. So basically, it's the one that does the redirecting. We will use this also in a little bit to actually ensure that a user is authenticated. If you're a fan of another framework, there may be slightly different ways to do this, but the actual core of the thing remains the same. So I will explain this in a sec. And then we have the store, which basically, to keep things as simple as possible, is just like a small database with just two data points, a user and a server information object. This would be pure JavaScript objects when we receive them. And it also has a computed property to check if we are authenticated, which basically just checks if the user is null, it means that you are not. And if the user is not null, if you actually have a user object with a name and an image, we assume that you are actually authenticated, and we allow you to continue with the page. So basically, most of the authentication logic is done through the store. This is explained in the how to create your own app in even more detail. But basically, it's a way to kind of like centralize all the communication, no matter where it's coming from your app, independently if it's coming from home or the stream view or the navigation, etc.
But with the simplest view app, you don't need to use a store. This is just a fancy additional convenience part of our architecture. But yes.
Yeah, it's basically, you usually use it when you have to access the same data from different places in your app that are not really connected. So if you need your user in several pieces of your application, you put it in the store so all of your application has access to it in a unified kind of way. But yeah, it's not really a full-on requirement of any view app in particular. And that's basically it for the overview. Let's actually switch branches. And, okay, no, wait a second. I'm skipping something. The last step is actually having your application running, which requires several things. First, it requires to run the npm run serve command. The same way we ran our Python command from the server folder, we need to run our frontend command from the frontend server. So in this case, we will do cd.frontend to actually be inside our frontend folder. And then we will do npm run serve. Server? No. Serve. Aha, beautiful. This, if you actually installed everything correctly, this should take a second, but I actually skipped the step for the most newbies in the room. Let me just kill that. First thing you should actually do, sorry for this, cd frontend, is to do npm install, which will download all of the necessary dependencies, view stuff, etc., to make everything work. This may take, depending on how much you need to download and use the internet connection, may take a minute. And then once that is done, you can do npm run serve, and you will start getting this starting development server, this percentage thing going hopefully upwards. And once everything is nice and ready, you should have your Speckle app up and running, but it will not work yet. Why? Because we haven't yet configured the app ID and the app secret and the rest of the information, the secret information that your app needs to have to communicate with the server. That is what we're gonna go do right now. So you should see something like this right now if you load it. But if you actually click the login register button, it would take you to a page that doesn't really work because you would be missing this file called, in the frontend folder, this file called .env.local. And this is where you specify your the Speckle ID from the app that we created previously, the Speckle secret from the app that we created previously, the actual URL of your Speckle server, which in our case is Speckle XYZ, a name that you want to give your app. This name can be anything. It doesn't really matter. We just use it to save stuff to local storage, and the URL of your backend. Remember that our backend is running on port 8000. So if we actually visit that, it will take us to this 127.0.0.1, but this is actually localhost. It's the same, the IP of localhost and the original IP of your computer are the same. So you can actually use localhost directly as your backend URL. let me just send you this. And if I can actually find the chat or Slack or something, there you go. So you can actually have, okay, there you go. So basically that contents you need to paste into this new file that you need to create called .env.local. And in that file, you need to add your Speckle ID from the app that you created and your Speckle secret from the app that you created inside these two variables. The rest of the variables are the same, so I didn't delete them. They should just do their thing. So now when you would need to actually reload, once you change this env local file and you add it, what this is actually doing is telling your view application that there is some variables in the environment that you're going to be running that need to be set and need to be accessible from your view app. And this is why we are preceding them all with view/app/whatever, because if not, view will not recognize them. This is a very view thing. We're just rolling with it. Just know that you need to put your app ID and your app secret here, and then do Control-C and rerun npm run serve in your front-end application. This, again, will take a second or two. And hopefully that will... Hello? Not yet. There you go. So hopefully what that would do, if you're running it from main and everything is coded correctly, this will actually send you to this this URL that is the same URL that we saw when we created the app. That was like the Speckle xyz/alfn/verify/our app ID and the challenge, which is this like random string of gibberish. No, so let's actually go and actually code that, and actually also code what happens when we go back and we allow that to work. So let me just move my way down to my Masterclass/start branch. So I'm just gonna, oh, wait a second, what have I done here? Okay, let me just, beautiful. I'm gonna change to my Masterclass start branch, which hopefully will contain some, I'm just gonna search for to do. There you go. So I added some to-dos to actually implement some stuff live in the demo. If we run out of time, I can always roll back and just explain the code in detail step by step, but I think it's more fun to actually see some actual code happening. So let's actually get down to it. The first thing that we should pay attention to is the source. I will get to it. I will get to it. The first thing that we should pay attention is in the Speckle utils. We're gonna implement the go to Speckle auth page, which is this redirection that we need to do from our app to the Speckle server that sends you to, hello? Doesn't send me anywhere. Ah, yes, I changed the thing and it no longer sends me because we no longer have an implementation. Okay, this is working. So let me just pull this up real quick. So basically, what we need to do is to send the user to this URL that we are creating that Speckle has told us that we need to send into. So the way you do this in JavaScript is you just do window.location equals to some string. So what string is this? Well, it's gonna be our, I'm just gonna live interpolate this real quick. Our server URL, which is coming from here, is the one of the environment variables that we set on our env.local, is the view app server URL. So we're basically putting inside a handy variable to be able to reuse it along. And it's server URL / authn / verify / our Speckle ID, which is in the same way our view apps our view variables are in process, env view whatever, the Speckle ID should always be there. It should also be there. So we're going to do process.env. I don't know how to write anymore. env.view app serve Speckle ID. And / a challenge. No, it was telling you that we need to add a challenge. Okay, so what is this challenge thing? This challenge thing is a security measure to prevent anybody from scooping in and identifying as yourself from another computer. Basically, we generate a unique string that we save in local storage. And then when the Speckle server sends back the information, we use that challenge to compare with the one that the Speckle server is sending. And if those do not match, you cannot log in. So it's kind of important, but at the end of the day, it's a very, very simple concept. It would work if we just use challenge as the challenge, but then again, that wouldn't be secure at all, because anybody could use that to kind of like snoop in. So I'm just going to use a very kind of dark but useful way of generating some random strings, which is I'm just going to generate a new variable called challenge and do math.random.toString, and then we're going to use the radix of I can't remember the explanation, but I'm going to use 36 here. And then we're going to do toSubstring and get just a chunk of it from character 12 to character 15. And we're actually going to do this twice. So basically, we're just generating a random string and another random string and mashing them together to ensure that it's like at most random. And I'm pretty sure there's more and better ways to do this, but this is a way that actually works. And then we're just going to pass in this challenge instead of the /challenge thing. I'm just going to pass in that specific challenge. But we're still missing a specific thing, which is we actually need to save the challenge somewhere. If we just generate a random string and forget about it, then there's no way we're going to be able to authenticate in any of our services. So we're going to use a default functionality of any web browser, which is local storage, to store that challenge somewhere. No? So we're going to use local storage dot set item. And then we're going to use as a key, I've already pre-computed some keys for us to be able to use. I have this challenge constant, which is basically using our app name and adding a dot challenge to it. Let's actually change that there. The key is my challenge, and the value, challenge all capitals, and the value is the challenge all non-capitals, the actual random string. So basically, we generate this random string, we save it to our local storage, and then we send the user to the Speckle server. So let me just reload that. And now if I hit login to server, I'm actually being redirected properly here. And when I hit allow, I'm not sure if I'm gonna actually exchange the token. Maybe not. Something happened. Well, let's go step by step. There you go. So basically, we still need to implement this other method here, which also has a big to-do on it. So what is happening here is that we send the user to this location, which is is located in the server, Speckle server. And when you hit allow, let me see if I can actually remove this from the router so we can actually see this live. I'm just going to kill that to stop the process from happening. Allow, there you go. So basically what happens is that the server will send the user back to the callback URL that you specified. So in our case was localhost 8080, and then it will add this query parameter called access code, and it will give you this like random number, like a totally random string. So once you're there, you have that, you need to exchange this access code that you have and the challenge for the actual tokens that identify you. So it's a two-step kind of process that needs to happen. First, you need to allow the Speckle app, and then you need to, with the data that you got back from allowing, you need to exchange that for some actual verification information. So let's actually do that, which will kind of like wrap up our OAuth intro. I'm just gonna redo that specific step and explain this in a second. Let me go back to my Speckle utils. So we now have to exchange the access code, but we really don't know where that happens. No, Speckle, the initial Speckle information just told us about the first URL. The second URL is in the documentation of how to do OAuth, if you're curious. But basically, we need to do a post request to a specific server, a specific URL in the Speckle server that is, let me do it, var URL is equals to, it's our server URL /auth/token. That's the URL of our server that we need to do the post request to. And in order to do a post request, since we're in the Chrome side of things, we can use the fetch API to do any request that we need, that is a REST request. So let's go ahead and do var the response is equals to await, because fetch is asynchronous, fetch, and then fetch requires some input to actually work. So I'm just gonna open a new object in there and see what we can do with this. It has to be a post request, so we have to add the method to our fetch input and pass it as post. We also need to add the headers of our application. And for this header, we just need a content type of application/JSON. So basically, we're telling it that the response that the data that we're going to send and the response that we're going to receive are JSON type. So we don't, so it deals with most of it for us. And then we're going to have to send a body So the actual body of the request, the actual data that we're gonna send to this requires an access code, an app ID, I will fill this in a second, an app secret, and the challenge. So these are the information points that we need to provide. The app ID and the app secret are environment variables that we set. So we can do process.env.view app speckle ID, and the secret is process.env.view app speckle secret. Remember that these are coming from the environment local file that we created. So they basically have the same exact name in all capitals. The challenge we stored in localhost, in local storage, using this capital all caps challenge key that we created. So in order to retrieve it, we can do local storage.get item and challenge. And we're just missing the actual access code, and the actual access code is being provided to us directly because we already hooked this up to the router. It's being dealt, the information extraction is already being dealt for us once we get to this point, and we just need to provide the access code that we're passing in as an input to the access code. And then once we've actually dealt with this request, we need to actually fetch the data. Var data equals the response dot, since we told that it was application.json format, we can do response.json. And since response.json is a promise or an asynchronous task, we have to do a wait to actually wait for that process to finish. And hopefully print, we exchange the data. Just gonna print that in the console, and I'm gonna add the access code to my initial print. So the last thing that we will be missing is to do something with this data, but first let's see if this is actually working. No? So let's go back to our actual front end, do a reload just to ensure. We click login. It takes us to where we wanted to go. And we can also check, once we're here, we can also open localhost 8080 again, open our developer tools in Chrome or whatever other application you use for navigating the internet. And if you go to application storage, local storage, you will see that you have your URL is right there to select. And inside here, can I zoom this? Is this possibly zoomable? No, this is very small. Sadly, this is tiny. But you will see that we actually have a challenge that was saved here with some that we can retrieve once we're done with the authentication process. So let's give this a go. We go to the AECtech Diff local and jump back and and I failed. I failed dramatically doing something. What did I fail dramatically to do? Do I have a typo somewhere? You see, the thing about live coding is that it's highly unpredictable. So we exchange the access code. Unexpected token emission at position 0. One second. If this goes badly, I will revert to actually going to the hard-coded version, which should go smoother than this. Aha, there we go. Now we have a response. We have a body. I don't know why this is not working. This is sad. This makes me sad. Okay, give me 1 sec. Okay, I'm just going to revert to the actual hard-coded one, which should work, just because live coding nightmares are haunting us. Yeah, this thing is not working properly. Let me just test that. No fail. Sorry for that. Let's see if we can actually get this thing going on our main branch. Ooh, it's reloaded nicely. Let me log out of there. Okay, so we were in our Speckle utils in Exchange access code, and we basically had our data. So I'm just going to console log got the data. We've got to actually see that actual response when we're flowing back to our application. And basically what you will get is an object with a token and a refresh token, which are the token is the one that you use to authenticate as yourself. But these guys expire. So you can, if it expires, you can use the refresh token to get a new token from it. Right now, the expiration is not one of our problems because I think currently the tokens last a month or two. So for our class, we're okay. We're not actually dealing with the actual refreshing of the tokens. But just so you know, this data object that we're getting as a response is basically a JavaScript object with a token and a refresh token item. So what we're doing is that if we actually receive the token, and if the token is successfully there, what we're going to do is remove the challenge that we generated randomly, save that token into local storage, and save that refresh token into local storage. So if you go back to your application, the challenge should no longer be there, and you should have this auth token and refresh token keys saved and ready to use. And this is what we use to send in any communication with the server to authenticate as ourselves. No, so we no longer use a password or anything else. This magical number does everything for us. And obviously, to log out, the only thing that we actually need to do is to remove those tokens and refresh tokens from the local storage. And if we no longer have them, we can no longer authenticate, and you're done. You have been logged out. So that's what the Speckle logout function is actually doing. So basically, that's like a super fast round trip to OAuth in general, and Speckle OAuth in particular. Feel free to interrupt me if you have any questions. I'm not sure if Claire is being bombed in the chat, maybe.
No. So I think we have about 25 minutes left. There are quite a few bits of the code that we haven't covered, like the GraphQL queries and the diff, the actual diff logic. If there's anything specific that anyone in the class would like to see, we can run over that. I think otherwise,
I think it would be interesting to have the GraphQL queries if anybody wants to actually see it, to see the playground and actually see where these weird things are coming from. But if anybody else has any priority questions, feel free to interrupt us right now. If not, I can give you a quick walkthrough, or Claire can if she wants to, from the actual GraphQL API playground that comes with the Speckle server.
I
So
just
you don't really
linked
need,
it in the chat. So that's an area where you can test your queries and see what is being returned before you use it for your code.
Yeah, and basically this is where all of these Speckle queries are coming from. We basically code them up in the Explorer, and once you have them ready to go, you just copy paste them into this constant as a string that you then have to pass as, where is it? The Speckle fetch, this one, that we then use fetch on our GraphQL API to pass the actual query. This is a GraphQL super specific way of doing a post request, and it's basically the same for any GraphQL API. So if you already know about this, you should be familiar with sending like this body as the query with some variables and creating your Speckle queries. But if not, let me just zoom that up like crazy big so everyone can see it, and show you how, without actually knowing absolutely anything from the GraphQL query system, you can use the tools, the GraphQL playground, to actually create some queries without really knowing anything from the API, because it does provide some autocomplete features that are super handy. So basically, GraphQL is divided into queries, mutations, and subscriptions. Queries are getting data, mutations are asking for data changes, and subscriptions are listening to data changes in the GraphQL. So the most important part, and the thing that we use the most here in this app, is queries. And what can you do with queries? The beautiful thing here is that you actually have autocomplete in the GraphQL. So you can just hit Control Space, and it will give you all of the options that you can have, that you can query from. No, let's say you wanted to query.
Let's try the stream that we just created.
Yeah. So if I wanted to first like figure out the ID of the stream that I just created through the backend, no, I will ask for the streams, and then the streams has a total count, a specific cursor, and a specific set of items. So I'm just interested in the items right now. And each item contains a specific set of information that I can ask for everything or just one specific thing. No? So I'm going to ask for the ID and for the name. There you go. Sorry for the pop-up. It was overshadowing my autocomplete. So if I run this right now, I would get a bunch of streams that I have access to with their ID and their name, and the structure of the response is this is how GraphQL works. It's exactly identical to the structure of the query that you created. So if you created a query that has streams, some items inside, and inside those items an ID and a name, you will have a streams key, an items key that is an array with objects that have an ID and a name. No, so it's like very common sense once you get to it. And now that we actually know the ID that we want to get, we can use another specific query for one stream instead of all the streams. And this requires some inputs that you can give it using parentheses. And in this case, it's going to be the ID of this thing. And it requires, again, some information to be filled in to tell the GraphQL server what information you want. So we just want the name and the data or the children. No, the commits. The commits. We want the commits. And this works in kind of like the same way. Commits have some a total count, a cursor, and an items. This is to allow you to do pagination. I'm just interested in the items right now, and inside the items, you have a bunch of stuff. We can get the ID, but we can also get the application, the source application, the author name, the author avatar, and the referenced object, which is the object that actually contains the data. Okay, so this will give us a list of, I'm going to remove the author avatar because it's too long and it's just confusing. Much better. So now this will give us a list of commits that are available inside this stream. As you can see, since I haven't specified a branch, I'm getting all of the commits. The 2 commits that I created from main that come from Revit, and the commit that I created that comes from Python. And I can actually ask them for the branch name. So you can see that this one is in the branch Diff, and this one is in the branch main. You can also ask for the commits of a specific branch using the branches input, and then asking for the commits on that branch. But let's actually go to the interesting part, the actual referenced object, which is the thing that actually holds the data. So we have this commits list. I'm just gonna kill it and recycle this query to go along. And we can also ask in any given stream, we can ask for objects with a specific ID, no? So in this case, it's gonna be that one that I just copied over. And again, you get an error because object requires you to actually provide some information that you want from it. In this case, we're gonna do the Speckle type, the application ID, and the children of data. Which one is the most interesting? I can't remember right now.
I think
data is the one with references, children is the one without, no?
And then actually data.
Okay, let's do data.
An object. It might be children data. Oh yeah, because if we want the reference ID. Let's get
I got the reference
first.
ID. Children.
So just a general note, these queries, so when in the Python SDK, when we're going through the backend, you saw there was a nice like clients.commits.get, and you just pass in the ID directly. That's because that method already wraps these GraphQL queries like nicely, so you don't have to actually figure out the exact query you need to write. We have discussed building out a JavaScript SDK at some point, in which case we'll try to reach like all feature parity with our C# and Python SDKs, and yeah, at some point maybe we won't have to write these GraphQL queries manually, and they'll be packaged nicely in a JS SDK. But for now, it's manual for any front-end apps that you're building.
Yeah. It's been low priority for us to do the JavaScript part because every JavaScript developer already knows how to do queries. So it's kind of like a pre-done thing that is not as useful as in Python and C#, which doing HTML queries is a pain. So we kind of like wrapped it in a more beautiful package. Let me 1 second because I screwed up and I got the wrong commit object, and this one is kind of like less interesting, I think. This is the diff one, no? Yes, so here you will see that in the diff object, you get a lot of different weird things kind of happening. Let me see, we'll try to fold most of it in place. So we're basically getting that same structure that we asked for here. So a stream with a name and an object. The object has a Speckle type and an application ID and a data, and the data object is the actual commit object that we sent. So this contains the ID of the original object, which is the one that we requested, but also all of the properties that we attach to it. So the reference objects are all meshes. If I actually kind of manage to pull this off, Speckle type, object geometry mesh. So they are all already meshes. They all come with like a render material, some texture coordinates, which are references of another object. So there's a lot of like database kind of concepts involved in querying your data from the application using this data endpoint. But if you actually use the children endpoint, you will see that now this actual data should be, if I remember correctly, nested properly. So we can actually ask for the data of that. Yes, and this will give you the raw children of all of the objects, which gives you a lot of raw data. So you have like several options to query your information depending on exactly what it is that you're aiming for and what it is that you require. You can ask for objects individually, one at a time, or you can just use the data or children endpoints to fetch most of the data directly. I see a question. When to use REST versus GraphQL? Do you have any recommendations? Yeah, exactly. That was exactly what I was going to say, Claire. Yeah, well, usually GraphQL is very, very neat at creating APIs, but terrible at actually uploading and downloading data. So we actually do have Speckle.guide. We actually do have in the developer docs somewhere in the, we have our GraphQL API, which is explained here. And we also have a REST API, which is precisely to improve performance on grabbing objects, specifically huge stream commits of plus 100 megas that require a lot of fetching. We do use an actual REST API for that, even though that same endpoint is available on the GraphQL API, but the GraphQL API is apparently not as performance efficient. So yeah, it's kind of like a very thin line between ease of use and performance-driven API decisions. But yeah, for the most cases, GraphQL should be perfect choice. I love it, to be honest. Yeah, feel free to ask any random questions for the last 10 minutes that we have pending, or if you're missing something that you would want us to go over, feel free to do so. Sorry, we didn't actually have time to fully explain all of the Speckle parts in the application, partly for demo errors and partly for having to explain too much.
You can go very briefly into the diff logic, and if you wanted to improve on it, like what other ideas for what you could do. Either I could screen share, or Alan, if you go back to the mesh diff file.
Yes, give me one sec. Right here.
The general logic is that we're retrieving all display meshes from our commits that we want to compare, and comparing the actual vertices of the display meshes. And if a vertex has moved, it'll try to find the closest vertex in the paired mesh and color it some pre-coded values of shades of red according to how far it has moved. So that's the diff logic is very basic right now, just for this demo. For instance, like the display meshes are generated from your BREP geometry. So if you're sending a solid from Revit or a BREP from Rhino, then when you say scale an object or Boolean a solid or a BREP, it'll change the generated display mesh. So that's why like we saw when we deleted that door in the Revit wall, that the coloring was a little funky. Instead of retrieving meshes, what you could do is check for BREP type if it's coming from an application that supports BREPs, and you can compare BREP properties directly. You can make the logic a lot more sophisticated to color edges. Instead, you could change the logic so that if you didn't care about changes in geometry and wanted to look at change in properties, from Revit, you can create a different display material and a render material and assign it to your mesh for the commit branch. So yeah, there's a lot of flexibility once you get your Speckle objects in from your server. There's a lot of creativity that you can use to manipulate them and change their properties accordingly for more sophisticated diffing operations. And if this is something that people are interested in, it could be a feature that we build into our front end automatically. I mean, it'll take some time to implement, and we have quite a few viewer changes on the way. But yeah, it's we're just getting started with the kind of applications and things that you can do on top of Speckle once you have your base objects and using our APIs to retrieve them.
Yeah, we have a question for you. Are you considering for the future to develop the connection from Revit IFC 3DM files uploading on Autodesk BIM 360 Hub? I don't think we actually have any official plans, but I've already shoved that idea several times under the door of Dimitri and Matteo. So hopefully it will happen at some point. I think it would be, like speaking clearly, a very, very useful and dope application to develop, to have like a live synchronization link, like every time you synchronize your work model in BIM 360, that it actually gets extracted and also sent to Speckle. So you would have kind of the best of both worlds. You will have all of the nice Revit to Revit BIM 360 kind of like workflows that they enable. And at the same time, you will have all of the connectivity that we provide that BIM 360 lacks, and it would all be synchronized. So yeah, I am looking forward to it, but we don't have any actual official plans. We are very community driven, so maybe leave a post in our community saying that you would like that. And maybe if it's not coming from me, it would get a little bit more traction. I would love to develop it, to be honest.
And our APIs for the question from Eric, could you explain a method for downloading a list of objects that share a known parameter? You can add query parameters currently, and I believe, do we have plans for improving our API currently?
There is plans for improving the query language. This sadly falls out of our knowledge pool. We need to have Christy here to explain all of this.
I mean, you can do things like, for instance, omit certain properties. We have a closure that we're using for our commit objects that is, it's just a performance feature that no end user would be interested in seeing. So yeah, I think a lot of the improvements will be in just filtering for the quality of the data that you get. I don't remember the actual syntax for applying these filters to our GraphQL queries. Our documentation could definitely be better. They're a little bit out of date currently.
Yeah, I have
there's a
like
limit.
real fresh example. I'm gonna post the link because Dimitri just got this question from someone else in the forum. So I'm just going to post that there. Hopefully we'll take you to the correct post. Basically, there's like a query object in the children endpoint for each of the objects. So let me see if I can actually roll back that. There you go. So in the object, you have the children field, and the children field actually, let me see if I can get this thing out, has some variables that you can put in it. One of them is the limit, which is how many children do you actually want to obtain.
And then with the query, you can add the parameter.
Exactly. You have select and query, which allows you to filter down. And in that link, Dimitri's shared a filter filter all your IFC doors in a specific level, I think it was. So you can do some powerful stuff. This is something that hasn't been extremely explored by any of our current users. It's just now starting to kind of like get traction. So we haven't really tested the limits and kind of like edge cases of this. And it definitely needs a documentation polish. So if you're really interested in that, again, please push a nice post in our community forum. And hopefully between you guys and the rest, we can get enough traction for this to happen. Since we're a small team, we have to kind of prioritize. Thank you, Stephen. Glad that you loved it. You can create your own connector using only the Python SDK, and that is what the Blender connector does. I think it's Blender. Blender, yes, Blender. Yeah, because Unity, C#, Unreal is C++. Yeah, it's Blender, the one that is Python based. So basically, if you go to our Speckle Blender repo, that is an example of a full-on connector that is all Speckle Py. It has not a single line of C# or anything else in it, and it works beautifully. No, it just depends on the target platform. What are the limits of the platform that you want to connect to? No, for QGIS is another one of our newly released connectors in super alpha state that is Speckle Py based. But sadly, most of the desktop applications that our industry targets are not very friendly with Python, and they are mostly C++ or C#. So there's no way out of there. But yeah, it's definitely a possibility to create your own connector, and we do welcome community connectors, and we will help in any way we can to get you going, which is something that we've done with the guys at EPFL. With their top solid connector, which is not openly released, but does exist. I'm not sure when they're actually planning on releasing it.
We have a few Bentley connectors coming from Europe as well. Yeah.
Yeah, it's a lot of stuff happening.
Anyone who has domain-specific knowledge for different APIs for software is definitely welcome to contribute. And we're willing to coordinate and help out however we can.
Yep.
Cool, thanks. This is pretty cool stuff. Actually, how does it work in terms of the bigger the models get? Let's say the more elements, the more data stuff. Do you notice, let's say, the performance with the GraphQL?
You do. This is why most of our connectors use the REST endpoints for actual data transmitting and receiving data. The GraphQL endpoints exist because of ease of use and exploration approach. Like if you have a small amount of data, you won't ever notice the GraphQL going slowly. But if you're trying to send a 200 megabyte JSON file, you're definitely gonna see that drop in your connection. While if you use the REST endpoint, since all of our objects are actually detached from each other and saved individually in the database, the server transport will open 4 or 6 connections at a time and start downloading from 6 different connections all of the objects. So it's actually at least 6 times faster than going through GraphQL, but it's actually faster than that.
Recently, we've Christy's been improving our like serialization and deserialization performance as well, but it's a common traffic problem of like the more performant you make something, the dirtier and more data people will send. So we always encourage like best practices when, like for instance, if you're creating a lot of nested base objects, like detaching where it makes sense to detach, things like not sending a bunch of empty like meshes with a bunch of empty vertices, and making sure that your data is clean to reduce the size of that is always helps, and to be aware of that on the developer side.
Of course.
But anyway, just for reference, I think it was last month, I did some tests with point clouds for a university that wanted to use point clouds in Speckle. So it was like, okay, let's see what we can actually throw at this. And I sent a 1 gigabyte point cloud in less than a minute, which is
really?
fairly fast. I do have a pretty fast internet connection, and it does depend heavily on that. But depending on the objects and the complexity, it's even if there's a lot of data, it should go up pretty fast. If you're receiving it in Revit, for example, Revit is famously slow at creating the objects in the database. So then you hit a funnel that you may receive it in like 5 seconds, and then spend the next minute just seeing things happen in your Revit model until it actually finishes. But that's kind of out of our hands, sadly. We do try to improve and make less of a data funnel on our side as much as possible, mainly because people will try and send massive skyscrapers fully modeled to Speckle, well, and it should
will, right?
Yeah.
Well, I think generally
work,
we've been approaching this interop problem as kind of a fuzzy interop problem. So we're not trying to replace your file infrastructure. It is possible to store an entire model on Speckle, but it's like we're not primarily trying to be a database. So a lot of it is like curating the data that you do want to send, things that are hard to do natively within your applications, extracting your parameter values from Revit, receiving them nice and organized in other softwares like Grasshopper, and performing operations on your data that aren't easy to do in your native like target and source applications. So that's like one of the perks. Like I think there will always be good targeted interop solutions out there, whether it's like Rhino inside or like other specific solutions that might provide higher fidelity, like model saving capabilities. But it's really like the nice thing about Speckle is being able to use a common format on the back end, your base object, for all of your data, so that when you need to compare, say, changes in your models between multiple applications, you can do that. You're not limited to like one specific workflow. So that's the trade-off.
Yeah, totally.
No, it's pretty cool. It's awesome. Now we probably need 3, 4, 5 days to actually dive into these 3 hours of information that you
yeah, I think we needed we should have booked the 6-hour day class.
No, it's great. Thank you.
All right, thanks everyone.
I think we have a last question from a couple of last questions. Can we use Speckle for hackathon? Totally yes. Speckle is totally open source. You can do Speckle for whatever you want, and you don't have to tell us about it whatsoever.
We would love to see people use Speckle for hackathons and post on our community the stuff that they're building.
Yeah, we're also happy to like if you're doing some cool stuff with Speckle and you want some kind of reverberation of broadcasting, we are happy to have guests in our blog post writing about specific applications or specific connectors that they're doing, use cases, etc., which is something that we do lack and we would love to have more of. So if you have some cool Speckle events or Speckle related developments that you would want to showcase, we would love to hear about it and give you like a little spot in our blog post to talk about it if you're willing. And then we have another question from Bob.
Developers section now, I think, with EPFL being our first guys.
Yeah, I'm not sure what ETL is, so I'm not sure if I'm qualified to answer this comment, Bob. Oh, yeah. Kind of, yeah. You can also use it for data. Like, we're very geometry centered, but at the end of the day, Speckle ends up being some JSON files in a SQL database somewhere in the cloud, no? So you can think of it as geometry or use it for whatever other thing you may need, a data storage layer with authentication and connection to other softwares. Thanks, Bob. You're welcome to joining us, and looking forward to your comments and hopefully improvements. If you have any, we would love to hear suggestions too. Cool. Well, if that's all, we can kind of call it a day.
Yeah, thank you everyone.
Sure, everyone is Speckle overloaded.
Definitely one of our longer presentations, I think.
Yeah. Yeah, thanks everyone for staying with us, and looking forward to seeing you around on our community, hanging around.
Absolutely. Thank you very much.
All right.
You're welcome.
Bye, everyone.
Bye-bye.
Bye-bye.